Hey everybody, Newland here. I wanted to explain meters used in electrical circuits, and I wanted to discuss a strange combination of parallel and series circuit that is sort of well, it shows up from time to time, and I thought I'd demonstrate it. First of all, we've got three kinds of meters, which are drawn like this. This is their circuit symbol, and we've actually used two of these, but probably not the third. Hang on, that's supposed to be an omega. So this is an ammeter for measuring current. This is a voltmeter for measuring voltage, and this is an ohm meter for measuring resistance. Ammeters must be used in series, and voltmeters must be used in parallel. And the ohm meter is really designed to be used on its own. So how do they work? So I've got let's say we've got a battery and let's give ourselves a little bit more wire there. We got a resistor, and we want to figure out how much current is flowing in our circuit. So here's our resistor, here's our ammeter, and here's our battery with EMF E, and this resistor has resistance R. The way that we could literally measure the current flowing through the circuit, which here's the positive side of battery, here's a negative, so the current would flow in this direction. This is the positive side of the resistor and the negative side, so there's a potential drop as we go across the resistor. The current, of course, can be calculated by using Ohm's law, where we could say that E equals the current times resistance. But the ammeter's job would be to directly measure it. So perhaps you know your EMF and you know what the resistance is, but you would like to literally measure the current. It has to be done in series so that the current literally flows through the meter. That's how they're designed. They are very low. The ammeter, low resistance. So the reason that's important is if the ammeter is not designed to measure the current that you're expecting in your circuit, you'll burn it out. Most of them have a fuse inside, and a fuse is a circuit element like this guy that has a piece of usually some sort of metal in there. Then that metal will melt when the current is greater than what's allowed. And when it melts, it literally breaks like this, and then current can't flow through it anymore. And an ammeter's job is to make sure, so this is a fuse. An ammeter's job is to measure the current in a circuit, but a fuse's job is to make sure that the ammeter itself isn't burned out. So fuses are designed to be removed from things like ammeters and voltmeters and ohm meters and other devices that use fuses and replaced. So if you inadvertently put too much current through your device, the fuse will prevent it from catching on fire or being destroyed forever. So that's how ammeters work. They must be done in series. So what if we wanted to build our own voltmeter? So let's say we've got a circuit like this, resistance. We know that the battery has EMF E. This is the plus and the minus. There's the plus and the minus. So it's, again, a potential drop across the resistor. The current is still flowing in that direction. So E still equals I times R. But if you wanted to actually measure potential difference, you could take a voltmeter and put it in parallel. So the voltmeter has high resistance, meaning that it has the minimum amount of impact on the circuit. You want very, very little current to flow through the voltmeter because the job is to measure the potential difference. So it saps just a tiny bit of the current by having a high internal resistance, specifically designed to work in parallel. if your voltmeter is not designed correctly, you'll end up pulling too much of the current through there and you'll affect your circuit. So instead of having a series circuit, you would have inadvertently made a parallel one. So the voltmeter is specifically designed to be placed on opposite sides of a device or a circuit element so you can measure the potential difference. Whereas the ammeter is meant to be put into the actual circuit, like actually in series. And the difference between the two is that ammeter has low internal resistance, meaning you better be careful about how you use it. And a voltmeter has high internal resistance, meaning that you can use it essentially more safely without being concerned. The ohm meter is different altogether. The ohm meter, let's say we're trying to measure this resistance here, and we actually attach an ohm meter. That sort of looks like an omega. I'm going to try again. Let's make our circle a little bigger. There. The ohm meter has its own, it generates its own small current. So the ohm meter is actually powered. Well, actually, typically we use a voltmeter, ammeter, ohm meter combination. And if you put them all together, if you have one device that combines all these things together, that's why we call it a multimeter. That's why they have to be, oh, I misspelled that. That's why they have to be powered, because they can do multiple things depending on how you wire them up and depending on what setting you've got it on. They can often also measure capacitance, and they can measure both DC and AC voltage. They can do a bunch of different things. So it's typically best to get yourself a multimeter, because you can have that thing do different things depending on how you put it in your circuit. But in the case of the ohm meter, you need to take your circuit element out of your circuit. Since the ohm meter generates a little bit of its own current, you want to take the resistor or whatever device you're trying to measure the resistance of, take it out of the circuit and put it basically in a space where you can hook up the ohm meter to it. You've seen me in class place the leads of a resistor with my fingers directly on the probes of an ohm meter, and that's because it basically can't do any harm. But sometimes people use ohm meters that have little alligator clips, so you can pinch them and attach them to your element, and then no voltage from the human would get in the way of measuring your resistance. Don't forget that the resistor has the colored bands, but it also has a tolerance built in. So if you're concerned about maybe the precision of your reading, you want to be mindful that resistors do have that tolerance built into them. Okay, that's how meters work in general, and in a minute I'll add on to this and do the complicated circuit I mentioned.